Hi there, my name is Dean Kensock. I'm with the Esri Content Development Team. I'm the CTO for Content Development, and I'm here today to talk about Esri location services for developers. In the presentation, I'm going to cover four main topics: maps, search, directions, and enrich. I'm going to spend a bit of time on maps because there's quite a few things that I wanted to cover for you there, and then I'll wrap up with some details on each of the other topics. So starting with maps, Esri has a very rich platform in ArcGIS for mapping content, and I want to introduce you to some of the types of content that are available to you as a developer. First and foremost, many of you are familiar with our basemaps. These have been around for many years. We have a wide variety of basemaps that are designed to support different purposes, from very neutral background maps to very rich foreground maps. One of the changes that you should be aware of in the last couple of years is we've introduced a second set of basemaps, vector basemaps, that are available for you to build into your apps. So we now have both vector and raster format basemaps, and I'll talk more about that in a minute. The data in these basemaps is coming from a variety of leading data providers, such as HERE, Garmin, Building Footprint USA, OpenStreetMap, and interestingly, a lot of data, millions of features from our GIS community. Let's talk a little bit more about the vector basemaps. There are several advantages to using vector basemaps in your maps and apps, and I've listed several of them here. One, there are many more styles available to you as vector basemaps than raster basemaps. There's a set of core styles, about 10 of them, that are available from Esri, and then several more creative styles available from Esri and other users and developers. If you would like to build your own custom styles, you can easily do that using vector tiles. You can turn layers on and off, you can change the colors and other rendering information, you can label with different languages, I'll talk more about that later, and you can also manage the treatment of different disputed places. I'll also talk about that more later. One of the benefits of vector basemaps is they look great on high-res displays like Retina devices. So if you're using our vector basemaps in a mobile application or an application where you have a high quality resolution display, you'll see much sharper features and labels. One of the benefits we see at Esri is that the maps are much faster to update. We can update all of our global vector-based maps on a single machine in a matter of about 30 hours versus the many weeks it would take to update our raster tiles. What that means for you is that you can get fresher data much more quickly. The maps are also more interactive. You can use them in intermediate scales, and it resamples the tiles client side so you get clearer rendering. We can also deliver the maps in different coordinate systems. We have maps in Web Mercator, Auxiliary Sphere, and GCS WGS84 for our global content, and then several our partner organizations around the world are publishing local coordinate systems of vector-based maps. And then lastly, if you're looking to take the maps offline for use in applications like Collector, you can take off a larger area of tiles in vector format than you can in raster format. So you can store larger areas on smaller devices. So what's new with our vector-based maps? As I mentioned, they've been around for a few years. Each year we're introducing new content and new styles. In the last year, since our last developer summit, we introduced a few new styles, including our community style, which takes full advantage of all the community content that's being contributed to our map. A new navigation dark mode style that's a complement to our navigation style and works great in mobile devices when you're in dark light conditions. And most recently, our newest National Geographic style base map. This has all the same content as the traditional Esri base maps, but in a very distinctive and rich National Geographic style. And as I mentioned, many of our maps are available in our GCS WGS84 tiling scheme. So this is an alternate global tiling scheme that's very popular with some of our user community. In particular, the defense intel community and our petroleum user community have a preference, in some cases a requirement, for using the GCS. So if you'd like to use that for your base map, there's a rich set of styles available for that too. As I mentioned, one of the benefits of vector-based maps is that they can be localized. So with our current vector-based maps, we have maps in kind of global language where you're looking at English primarily at all scales, local language where you're looking at English at small scales, and then local languages like French or Thai as you zoom into large scales for a given country. And then in the last couple of years, we've introduced several variations of these maps in currently 18 different languages. And in the next couple days, it'll be a total of 20 languages as we add language support for Dutch and Ukrainian. So what this means is that if you specify that locale for the base maps, you can see the labels at small scales also in these other languages. So for example, if you're using French as your language and you're zoomed out to smaller scales, you'll see the names of the continents and the countries and the water bodies in French. And then as you zoom into places like France, you'll continue to see the content in French. In other parts of the world at larger scales, you'll continue to see the content either in English or the local language for that country. Another important capability of our vector base maps is that they do support different treatment of boundaries and places around the world. We recognize that not every country shares an interpretation of different disputed boundaries and places. So we've built into our vector tiles the ability to adopt different views. For example, an India view that shows the India preferred boundaries and place names for their part of the world. So those are available in ArcGIS Online. If you select a region in ArcGIS Online that has custom views, you'll see those by default. And if you're a developer building an application, you can take advantage of those unique styles in your application if you're targeting a certain market that has preferences for those types of treatments. And then lastly, if you would like to build your own vector tile styles, you can do that through our new vector tile style editor, which is available off of the developer site, developers.arcgis.com. This allows you to create custom styles beyond the ones that are available from Esri to maybe adapt to a local coloring scheme of your application, or maybe the branding template for the organization that you're building the map or app for. So what's next with our vector-based maps? So there'll be a lot of new content appearing later in 2020. We intend to continue the localization. So as I mentioned, we'll support about 20 different languages as of March 2020. Over the course of the next several months, we intend to support all the remaining languages that ArcGIS Online supports. We're also adding new data and layers to our vector-based maps. We've announced earlier this year the addition of several places, several million places initially for the United States that are available. I'll talk more about that later. And then later this spring and summer, we'll be introducing vector contours and vector hillshades. These will be introduced as separate vector tile layers because of their size and complexity. And then we will have specific styles like topographic that take advantage of these new features and build them into various layers and web maps. So if you're looking to build rich outdoor maps, for example, these contour lines and vector hillshade will be useful. One important note about raster-based maps, we announced last year that we were going to be migrating our raster-based maps into mature support over the next couple years. So that process has begun and will continue in 2020 and 2021. So what this means is that over the next year and a half to 2 years, we'll be transitioning many of the raster-based maps into mature support. This means that the maps will continue to be hosted by Esri, but not actively updated. The information about these base maps is available on our lifecycle support document that you can find on esri.com and ArcGIS. And we'll continue to maintain these maps for the next 2 years. So popular maps like OpenStreetMap and World Topographic Map will be maintained through 2021 in terms of updates. And then some of our maps like World Imagery, World Hillshade, and the ocean base layer will continue to be maintained indefinitely. We do not have any plans to move those maps into mature support because they are required to be delivered as raster tiles, and they'll continue to be offered by Esri for the foreseeable future. So if you are using any of our raster tile base maps in custom apps that you've built, either through a web map or directly, we would strongly encourage you to start planning the migration of those to vector tiles, ideally this year, but certainly by next year. One of the new apps that we released last year that you should be aware of is our new Community Maps Editor app. So if you're a user of our base maps and you'd like to enhance our base maps with additional detail for high priority areas of interest, maybe parks or schools or recreational areas, you can use our Community Map Editor app to create features that will be used within our base maps. So you can use this app for free. You can go to arcgis.com, search for Community Map Editor, and find the group. You can join the group with your ArcGIS Online subscription account, and then that will allow you to create and edit features in your web browser. There are a variety of features that you can create, things like buildings or parking lots or recreation areas, including sports facilities. You can create those features using our imagery as a backdrop in the application. And then the features you create will get reviewed by Esri staff, and if they are accepted, they'll be integrated into the Esri base maps. One of the great things about the Community Maps Editor app is it's built with some pretty advanced editing tools using some technology from our partner Esri UK called Suite. It allows you to do things like snap to features, draw precise curves and angles, use pre-built stencils so you can easily create many types of features like baseball fields or tennis courts or basketball courts. You can copy and paste features if you're doing multiples of a certain type. So within minutes, typically, you can enrich an area of interest within the app. And then, as I mentioned, those features get reviewed by Esri, and then if accepted, they're included in a subsequent update to our vector base maps, which typically happens within a month. And then also those features that you create become available to you and other users as open data. So we will publish that data back out as a hosted feature layer in ArcGIS Online under a Creative Commons by attribution license, and then you and other users can access that data. And if you'd like to integrate that data into other platforms like OpenStreetMap, you're able to do that. I mentioned earlier that we're introducing some new types of data, including places. So I wanted to give you a little bit more information about that. This has been a common ask from several of our developers in particular. We want to integrate places more fully throughout the ArcGIS platform. So what do I mean by places? Well, places are different types of points of interest, things like stores or restaurants or hotels or museums, places where people tend to spend their time or money. We have some of these in our base maps today, but not very many by design, because a lot of our users wanted to overlay their own points of interest. But now with our vector base maps, we are able to integrate more detailed places into the map, and then users can decide whether to turn those on or off. So initially, the places will be available for visualization. There will be a new places layer in the Esri vector base maps. And as I mentioned, there's now a beta version of that available for places in the United States. Those places will be displayed by default in selected styles, like navigation, for example, but you'll be able to turn them on in other styles if you choose. Later this year, we'll be integrating these same places into other capabilities in the ArcGIS platform. First will be our search capabilities for our World Geocoding service. So you'll be able to search for these places by name and type in our search capabilities. And then at a future date, we'll be integrating them into our directions services. You'll be able to use those for place-based navigation, things like turn left at the gas station, that type of thing. So the data that's going into our places layer is also going to be coming from a variety of leading places data provider. For the United States, we selected SafeGraph Places as our primary data source, and that's what's available now in beta. And then internationally, we're going to be primarily using Here Places in places outside the United States, and then some other local sources where that makes sense. So let's switch gears a minute and talk about another type of map in our platform. Actually, the most popular map in our platform for the past few years has been our World Imagery Base Map. That's our flagship imagery base map that's designed to support the latest high-resolution imagery. So this is a multi-scale base map featuring the most recent high-resolution imagery that we have from various sources. One important thing to note about this map is that it does include metadata information. So if you want to know more about the imagery that you're viewing, you can use the layers built into the service to discover metadata with information on the source of the imagery, the acquisition date, its spatial resolution, and accuracy. A few years ago, we announced a partnership with Maxar, formerly Digital Globe, to update large areas of the World Imagery Map. And over the last 3 years, we've done extensive updates to our World Imagery Map using that content. In most areas, we've done 3, in some cases 4 updates, collectively updating over 250 million square kilometers of imagery in the last 3.5 years. The imagery we've licensed from Maxar includes 2 primary sources. One is a product of theirs called Vivid, which is a worldwide mosaic of imagery at nominally 50 centimeter resolution. And then also a product called Metro, which has even higher resolution imagery for 1,000 metropolitan areas around the world that Esri has licensed. And over the last couple years, based on feedback from ArcGIS users, Maxar has been making some enhancements to this imagery to improve the currency, clarity, and accuracy. I'll talk more about that in a minute. In addition, the World Imagery Map also includes content from some non-commercial sources from our GIS user community. So just like in our Basemap services, we accept content from our Community Maps program, we do the same with our Imagery program. So we have hundreds of contributors at national, state and provincial and local level organizations who are sharing imagery with us. And in many cases, this provides the most detailed or most recent aerial imagery available. So you'll find hundreds of communities around the world that are providing content. You can see a couple examples listed there. So I mentioned some of the enhancements that Maxar has been making to the imagery. I wanted to highlight a couple of those. So currency. One of the things that Maxar has worked to improve over the last couple of years is their refresh cycle. And they're now able to commit to updating all of their Vivid mosaic worldwide on an annual basis. So that means that all of the production blocks for Vivid, and you can see a map on the upper right showing worldwide coverage, all of the production blocks that they have coverage for Vivid are going to be touched every year with updates. And each of those production blocks is expected to have at least 50% refresh within the production block. It's often a challenge to collect fresh imagery in many parts of the world given cloud cover. It takes many passes, typically of the satellite, to capture enough imagery to make a near cloud-free version. So it's quite an undertaking to build out that mosaic and update it on an annual basis. But Maxar is increasing the amount of updates that they're able to perform each year in their core product, and we're making that available to you. Another thing that they've been working to improve based on our feedback has been the resolution of the imagery for the metros. So previously, the metros ranged from 30 to 50 centimeter resolution, but with some new acquisition capabilities and production capabilities, they're now committed to delivering 30 centimeter imagery for all of the 1,000 metros that we license for use within World Imagery. And then lastly, one of the comments we got from many of our users was wanting to improve on the positional accuracy of Vivid. Now previously, the spec called for an accuracy of 10-meter resolution. But through some enhancements to the production pipeline, Vivid going forward will have a positional accuracy of 4 to 5 meters, which is significantly better if you're using that as a source for data collection. So the first enhanced versions of Vivid were released last year for the continental or contiguous United States. And over the remainder of 2020 and perhaps into early 2021, the remainder of the world will be updated with this enhanced versions of Vivid and made available through World Imagery. So another service that we released recently that's been quite popular for our users is something we called Wayback, or World Imagery Wayback. For many years, users have asked about getting access to earlier versions of imagery. They've been excited to hear about the updates that we're making to our default World Imagery Map, but in some cases, they also wanted to have access to the earlier versions of imagery that were available. So last year, we introduced Wayback. What this does is provide access to over now 100 versions of World Imagery going back 6+ years. Beginning in January 2014 through today, we have every version of World Imagery that's been released published as a performant tile layer service, as a WMTS service. And each of these layers, like I described before, comes with metadata for the vintage of the imagery in that version of World Imagery over that 6+ year period. As we update World Imagery every 3 weeks, typically, we introduce new content into World Imagery, and that imagery immediately becomes available through Wayback. So you always have access to the current version of World Imagery and every version preceding that, going back to January of 2014. Collectively, that accounts for quite a bit of imagery. It's about 500 terabytes of imagery cache that's now available to you through our World Imagery Wayback. And this is freely available to you through your ArcGIS or Esri software. So we have a lot of Basemap imagery like I described, but we also have other sources of imagery in our platform that are multispectral imagery that you can use not just for visualization and analysis, but you can also do other things with it. So there's several examples of that, including Sentinel and Landsat. One I wanted to highlight is another data set called NAIP, or the National Agricultural Imagery Program. This is a program for imagery in the United States where they have coverage for the contiguous United States going back several years. And through our NAIP image services, where the imagery comes from the USDA Farm Services Agency, we receive multi-band, 4-band imagery that supports the traditional natural color view, as well as other band combinations for color infrared and NDVI. We have NAIP imagery going back for 8 years, starting in 2010 through 2018, which will be available very shortly. And then the NAIP 2019 imagery has been collected, and that'll be available from USDA later this year. This service requires that you use an ArcGIS Online subscription to access it, but it's freely available to you. One of the new things we've done with NAIP, based on your feedback, is publish, in addition to the image services, a tile layer that's optimized for performance. So we're starting with the latest version of imagery, the most recent imagery, which at the time we created that was the 2016-2017 imagery. And then we'll be updating it both with the newest imagery, the 2018 imagery we received recently, and then in the future versions of imagery like the 2019 as it becomes available later this year. And then we'll also go back in time like we have with Wayback. So you'll have access to both newer and older versions of NAIP imagery, but in a high performance tile service format. So switching gears again, let's talk about some other types of maps that we have on the platform. One of the other popular types of content is demographic maps. For many years, Esri has provided access to demographic maps for the United States and other parts of the world. We actually have a team of demographers at Esri that compile current year and 5-year forecast demographic data for the United States with several thousand variables that we maintain. And this data can be used for various purposes, including mapping, and as I'll describe later, also enrichment capabilities. You can build these maps into your web applications, your mobile applications, and into your desktop applications. This content is what we call premium content, meaning it requires a subscription to access the content, and it costs some additional amount of money, either to access up front or to consume through credits. So with the demographic maps, you consume that through credits, which is, I believe, 10 credits per 1,000 transactions. So the credit cost is quite nominal, and that unlocks a lot of the current year demographic data. We are currently making available the 2019-2024 data of the current year and the 5-year estimate. This was released last summer. And then in the coming months, by late June this year, we'll release the 2020-2025 data, and that'll represent a July 1, 2020 estimate of these thousands of variables. If you're interested for data outside the United States, we have international demographic data for over 130 countries worldwide. We have some basic demographics for all of those countries with about 100 to 150 variables for each country. And then for some countries like Canada, or the Netherlands or Germany, we have more detailed demographics similar to what we have for the United States. Another source of popular demographic data for the United States is the U.S. Census American Community Survey, or ACS data. About a year ago, we introduced a new set of layers in ArcGIS Online that expose some of the most popular variables from ACS as ready-to-use, publicly available, anonymously accessible layers. And we've built a really nice process where within just a couple days of the census data being released, we're able to update a number of live feature layers in ArcGIS Online, publishing maps for various topics on housing, population, employment, income, and more. So last December, for example, we released the latest 2014 to 2018 ACS estimates within just a couple days of that data becoming available from the census. If you'd like to learn more about this, you can visit the Living Atlas blog, search for ACS, and you'll find out where this content can be accessed. And as I mentioned, it's freely accessible content in ArcGIS Online that's available through the Living Atlas as well as through open data. A similar type of service that we make available, but for a very different type of content, are our live feed services. And these have become very popular over the last few years. What we've done in the last couple years is migrate many of these live feeds over to hosted feature layers in ArcGIS Online. And we did that for a couple reasons. One, we wanted to improve the scalability of these services. What we see is a lot of these live feeds become extremely popular after an event like a natural disaster, an earthquake, or a hurricane, or some other type of severe weather condition will immediately drive up the usage of these layers. And we wanted to take advantage of the scalability of ArcGIS Online in the cloud to serve out this content. The other thing we heard from our users is they wanted to have it be more easily accessible to them. So when these events happen, they want to be able to quickly add these layers into their maps and apps. Previously, these layers were available as subscriber content where you need to be signed in to access the content, and you could build them into your apps, but you needed to embed tokens to do that. With these new hosted live feature layers, we've removed that requirement, so now they're available as public content, so it's very easy to add this content into your maps and apps and take full advantage of the scalability of ArcGIS Online and the caching capabilities that we have. So you can discover these layers again in the Living Atlas if you search for live feeds or go into the environment category and look for Earth observations, or through a live feeds group that you can find in ArcGIS Online. And as I mentioned, these content are now public content where no sign-in is required. I wanted to talk about another popular type of content that's available in the ArcGIS platform, some things we've done in the last couple of years, and then some new things that we're introducing now. So many of you are users of OpenStreetMap. Some of you might even be contributors to OpenStreetMap. If you're not familiar with it, OpenStreetMap is essentially a wiki open map project that's been around for about 15 years, where there's a community of millions of volunteers who are collectively editing a live street map of the world. And in many parts of the world, it is the best available content, and it continues to get better. A couple years ago, Esri introduced an OpenStreetMap vector-based map. This was an updated version of an OpenStreetMap map that we've made available in the platform for the past 10 years. For many years, we've provided access to OpenStreetMap as raster tiles hosted by OpenStreetMap themselves. In this case, Esri is hosting a copy of OpenStreetMap data, generating our own set of vector tiles, and then making that available through ArcGIS Online as a vector-based map. This OpenStreetMap vector-based map is updated every 3 weeks. Every 3 weeks, we take a snapshot of the OpenStreetMap data at that point in time, and we generate a new global set of vector tiles. One of the great things about this map is that it's freely available to all users and developers, both within the ArcGIS platform and beyond. We provide it under an open Creative Commons by attribution license, which means that you can use it freely in your maps and apps as long as you provide attribution back to the OpenStreetMap community. We now provide multiple styles of OpenStreetMap's vector-based map. You can see a few examples here on the slide, such as the default style with OSM cartography, OSM with relief, their cartography, but with a shaded relief background, and then some creative styles like the blueprint style. and then a few more styles such as canvas that I'll show you in a minute. And if you'd like to deploy this map on premises for use behind your firewall, that option is now available as well through a new product option with our data appliance. A new capability that we've recently announced, in addition to our vector-based maps, is a set of OpenStreetMap feature layers. So what are these? Well, this is not a tile version of OpenStreetMap. This is a live version of different layers within OpenStreetMap of the data. So Esri is providing OSM data that will support visualization, as our vector tiles do, but also analysis and extract capabilities. We'll do this for individual layers of OpenStreetMap data, things such as buildings or amenities or highways that are available through the platform of OpenStreetMap. And what's cool about these layers is that they're very actively updated. These live feature layers are updated with minutely diffs from OpenStreetMap, so you have access to the latest available updates at all time. Because they're published as live feature layers, you can restyle the layers in ArcGIS Online, you can customize the pop-ups, and so forth. So we're just now introducing these layers. We recently published a set of feature layers for North America, which are now available in beta, and you can find information about this in the Living Atlas blog. And there's a group available in ArcGIS Online. Search for OpenStreetMap layers as a group, and you'll find this OpenStreetMap layers beta group. In the next few weeks and months, we'll be adding all the remaining regions. Next after North America is Africa, and then we'll be expanding to other regions throughout 2020. And as I mentioned, some of the benefits of these hosted feature layers are that they're designed to be more scalable and performant. So because they're hosted in ArcGIS Online and published publicly, we can take advantage of the elasticity of the cloud and provide a high level of performance and scalability. And we also can support additional capabilities for things like spatial analysis. So let me give you a quick preview of some of these layers. So here I'm looking at ArcGIS Online, and we've created a new organization, openstreetmap.maps.arcgis.com. And you can see here on the home page that this is an organization that's managed by Esri, and we're using this organization to feature a variety of the content that we make available with OpenStreetMap. So if you go to the gallery, you can see some of the content that we're featuring, including various styles of the vector base map, and then individual layers that like I was describing before. So let's take a look at some of these layers. So now I'm in the map view of ArcGIS Online in that organization, and I'm zoomed into San Francisco. I was looking at a blog recently where they talked about some proposals by the PTA in California to limit access or the ability of liquor stores in California to operate within a distance of schools. Within 600 feet is what they were proposing. So I wanted to experiment with that to see whether we could model something like that using the OpenStreetMap layers. So a couple of the layers that we make available for OpenStreetMap are educational establishments. And they're available both as points and polygons in ArcGIS Online. So I'm going to turn off the polygons, and then we'll look at the points specifically. And you can see that there's a variety of educational establishments, universities, colleges, schools, and kindergarten. Well, in the case of this proposed regulation, it would only apply to schools, not colleges and universities. So I want to create a filter on this layer. So I've created a copy of the layer, and now I'm looking at OpenStreetMap schools. And I can look here and see that I've created a filter where amenity is school or amenity is kindergarten. So it's excluding the features where the amenity was a college or a university. So now I have the layer that I'd like to do my analysis of. How could I do that? Well, because these are feature layers in ArcGIS Online, you're able to use some of the analysis tools. So if I select the analysis tools here, I can see what's available. So in this case, I would want to use the proximity tools and create buffers. And I want to create a buffer around these schools. So I've selected that layer. I'm going to specify the size. The proposed regulation was 600 feet. I'm going to add a little bit to that because the schools themselves are not points. They're a little bit larger, so probably about 200 feet radius. And so I could select 800 feet and then run the analysis job to generate the buffers around that? Well, in the interest of time, I've already done that. So I'm going to turn on this buffer with an 800-foot radius. So now you see all these circles where there's an 800-foot radius around these school points in the OpenStreetMap data. So now I want to see what features might fall within that radius. And I'm interested again in liquor stores. So there's another layer in OpenStreetMap that we've published for shops, different types of stores. So I'll turn that layer on, and you'll see that there are a lot of shops in San Francisco, not surprisingly. If I go to the legend again, I can see some of the different types of shops. These are some of the more popular types of shops that have been tagged in OpenStreetMap, and I can see one of them is alcohol. That's the tag that's used in OpenStreetMap for liquor stores. So again, I can create a layer that's just showing those, and that's what I've done here. I've got a liquor store layer that's a derivative or a copy of the shops with a filter, shop is alcohol. So it's just showing the shops that are liquor stores. And I can see here there's a concentration of them. Because of the map I'm looking at, it's a little difficult to make out some of these features. So I'm going to change the style to something a little bit more suitable. These are all different flavors of OpenStreetMap map, just in different styles. So I'm going to select the light gray canvas style so I can see these features a little bit more clearly. And now I can see there's a kind of an interesting concentration of them here. So I think I've got a bookmark for this area. So I'm going to zoom in here. And I can see that there's a concentration in this neighborhood, which is the Tenderloin district in San Francisco, which, if you might be familiar, is a kind of a notoriously gritty community. So the good news is there are a lot of liquor stores there, but there aren't a lot of schools there. But in the other surrounding neighborhoods near Nob Hill and elsewhere, there are some schools, and you can see there are a couple liquor stores that are well within proximity of that. So I can click on this feature and see that this one school has a couple liquor stores within its vicinity. So if I were interested in promoting this regulation, I might want to drill into this in a little bit more detail and see what could be done to mitigate this type of an issue. So here hopefully is a good example of how you can use the OpenStreetMap data. You can bring in layers from OpenStreetMap through ArcGIS Online. You can quickly focus those layers on topics that are of interest to you, and then you can do some types of analysis within ArcGIS Online to answer some questions and maybe share this out as a map or an app to communicate your concerns or your suggestions. So a little bit about the integration of OpenStreetMap with ArcGIS Online. I mentioned that we are syncing with OpenStreetMap. So imagine that there's an OpenStreetMap database in the cloud that's being actively edited by users around the world. Every minute, a diff file, a planet file, is released with the changes that have been edited in that last minute. We download that planet file from OpenStreetMap, and then we load that into a geodatabase in ArcGIS Online for a hosted feature service. We have layers for points, lines, and polygons, which are nodes and ways in OpenStreetMap. And then from that, we can build various feature layer views for individual layers like buildings or amenities or shops, like we were looking at previously. And then those views can be added into ArcGIS Online, Map Viewer and Scene Viewer and other apps, and you can build custom versions from there. And then again, we're continuously updating with minutely diffs. So if you make an edit in OpenStreetMap, you'll see that edit appear within just a couple minutes, typically in ArcGIS Online. So that's just a quick tour of several of the different maps that are available through ArcGIS Online. There are many more available, thousands of maps available in ArcGIS Online. And if you'd like to discover more of those, what I would recommend you do is visit Living Atlas, which is built into ArcGIS Online in the content page. There's a tab of content where you can add it from the Living Atlas. Or you can go to the Living Atlas website at livingatlas.arcgis.com. Here you'll find thousands of maps and layers from Esri, but also from our users and partners that cover a wide variety of topics and are actively curated by Esri. So in addition to the Esri content, you'll find examples of partner content, things like high-resolution imagery from partners like Nearmap, or real-time traffic information from partners like Waze, and then other types of content like weather data from NOAA and so forth. So take advantage of this high-quality content that's coming not just from Esri, but from our user and partner community as well through the Living Atlas. So that's a lot about maps, and there's quite a bit more we could talk about, but I'd like to switch gears now and talk about some of the other capabilities of the ArcGIS platform and of our location services. So one of our other very popular capabilities is search. So with search, we enable several different capabilities. We oftentimes refer to this as geocoding. And there's really three primary types of geocoding that we support in ArcGIS Online. There's what we sometimes call geosearch, where you're typing in a place like Los Angeles, and you're converting that string, that place name, into coordinates. So if you type in Los Angeles using our search capability built into ArcGIS Online or to Pro, you'll find a list of candidates that are sorted by likelihood. And then you can select one like Los Angeles, California, and it'll take you to the centroid of that location or give you the bounding box envelope that you can zoom to as well. So the intent of GeoSearch is to quickly find a place and typically navigate that on the map and then dispose of that location. You're not storing it. Another use case is batch geocoding. This is when you might have a table of records, maybe 1,000 or 10,000 or 100,000 addresses or place names, and you'd like to batch geocode those. Send those in as one request, maybe through an asynchronous request, and then get back coordinates for those full set of addresses and places, and then store those results for future use. So this is a premium service capability of our platform. It's built into ArcGIS Online, it's built into our desktop software, and you can also access it through our APIs, both JavaScript and REST. And you can use it to create point layers that you can then store for future use. And then a third popular capability is what we call reverse geocoding. This is where you're starting with a coordinate, an XY coordinate, and you want to convert that back into a string, into an address, a structured address, or into a place name. So you pass in the coordinate, and then you receive the location of that coordinate. So these are all exposed to you through our World Geocoding service, which is accessible through a variety of applications like ArcGIS Online, mobile applications, as well as desktop applications like ArcGIS Pro. And then for developers, of course, we expose this through our APIs, a variety of APIs, including our JavaScript API, our various runtime SDKs, and our native REST API. So you can use that API to access any of these services or capabilities that I described. And it's a global geocoding service. So we have place level data, things like Los Angeles or Paris or Eiffel Tower worldwide. And then we have address level data for over 140 countries around the world. So the map you see on the slide shows the level of quality that you can expect for different countries. So there are some level 1 countries like in North America and Europe and parts of South America and Asia, where we have very high quality data from our commercial providers. And then in some parts of the world, we may have less detailed data. And you can see through this coverage map where we have different levels of detail. And if you look at this live map on our website, it'll give you additional details of what you can expect in terms of match rates and match quality. We've been doing quite a bit of work over the last few years to enhance our geocoding service. I won't cover everything, but a couple examples. One, like with our Basemaps and like with our Imagery, we have an active Community Maps program for addresses. So many of our users are maintaining high quality address point data that's being integrated into our World Geocoding service. And oftentimes this improves on the positional accuracy of the locations that we get from our commercial providers. So if you know of cities or counties or other communities that have address data and you'd like to see it included in our geocoding service, please let them know or let us know about its availability. And you can also refer them to our Community Maps website at communitymaps.arcgis.com, and they can register and start sharing their data. Another recent capability that we added to improve the quality of our geocoding is an ArcGIS Online Locator view. So this is a new capability that came out in the last year that allows you as an ArcGIS Online organization or user to set some preferences about the geocoding that you might perform. So one of the preferences you can set is the location for an address. So for many addresses, we have multiple XY locations. One location might be on the side of the street. Maybe it's on the part of the segment and on the side of the street where you would expect to drop off a passenger if you were going to take them to an address. These are very good for routing use cases. So you can specify that location, the side of street, as the location that's returned. That's the default that's returned for world geocoding. And then for many addresses, we have an alternate XY location, which is a rooftop or parcel centroid location, which might be more suitable if you're looking to display the address on a map where you don't want to show it necessarily along the street segment. You want to show it on the building or on the center of the parcel that is the location of that address. So you can set that as your preference in the ArcGIS Online Locator view. If you're a developer, this capability has been available to you for a little longer. It's the location type parameter that you can pass in through the APIs, and so you can specify that through your custom apps as well. And then another capability of the view is to select and define specific countries that you'd like to search. So maybe you're building an app just for the United States, and you want to let people put in addresses and you don't want any false positives of addresses outside the United States, you can build a locator view that's limiting search just to the United States. Or maybe you're building an app for Africa and you want to limit it just to the countries of Africa. You can define that in your view, and then you'll only get suggestions and matches for locations within that selected set of countries. So switching gears, let's talk about directions. So this is another very popular and essential part of our platform where we provide some interesting capabilities. And I'll talk more about each of these here in a second. But it includes routing, both simple and advanced, live traffic, drive time, and origin destination. So let's drill into each of these a little bit. So routing and directions. With our routing capability, you can solve routes for both the fastest or the shortest route, depending on what your priority is. You can do simple point-to-point routes, A to B routes, or you can have multi-stop routes where you can order the stops, even with specified time windows. So this can be very useful if you're doing kind of the traveling salesman problem. You want to make 10 stops in a day. You want to do them in the most efficient sequence. And maybe you've even got some time constraints. You need to be at a certain stop at a certain time of day. You can pass that in and take advantage of that. And one of the nice things is you can pass in impedances, which are points of congestion or construction that are along the route if you want to avoid maybe the freeways or avoid certain points in the route at a given time of day. So one of the types of impedances that's very common is traffic. So part of our routing capability is access to traffic. We have both dynamic traffic, which you can visualize in map form like you see in the lower right. And then we also provide access to live and predictive traffic that's updated every 5 minutes. So if you're solving a route and you specify a time interval in the next few minutes, it'll factor into your route current traffic conditions, and it will create impedances based on congestion or construction along your route. If you're predicting a route in the future, maybe you're planning to drive to LAX on a Friday morning at 8 o'clock and you're doing this in advance, it'll use historic traffic data to factor that into your route planning. Another popular capability with our routing service is drive time areas, also known as service areas. So these are areas that can be reached within a given travel time, like 5 minutes or 10 minutes or 15 minutes, or distance, like travel distance of 5 miles, 10 miles, 15 miles. And it also supports various types of routes. You can specify different types of vehicles, cars versus trucks, different traffic conditions, and also different travel modes like walking versus driving. So in the example you see in the upper right, that is a 10-minute walk area around a point location in Manhattan, in Chinatown. So from that point you see the area, the polygon surrounding that point is the distance you could expect to get in a 10-minute time frame walking. And so that can be very useful for things like service area analysis. Is this coffee shop servicing an area that I care about demographically, for example? Or what is the service area of a given location of a store or a hospital relative to its neighbors? And then another more advanced capability is our origin destination, or OD cost matrix. This provides a distance table with the least cost paths along the network from multiple different origin and destination locations. So the cost in this case is not the straight line distance, it's the network distance, traversing that network from the various origins to the destinations. And then that is returned to you in an OD matrix that you can use for analysis. And this can be very useful for fleet planning, optimization, maybe for accessibility analysis, and so forth. So all of these capabilities are available through our directions services. Lastly, I wanted to talk about enrichment, which is a capability that maybe some of you haven't taken advantage of as a developer, but really is a distinguisher and adds a lot of power to your capabilities. And there are a few specific capabilities that are part of our enrichment. This is exposing a variety of data, primarily demographic data, but also environmental data as well. And it has a few unique capabilities. One of them is the ability to query demographic data for an area of interest. So in this example, we're finding a location, we're looking for a distance around that location, maybe it's a 5-mile buffer, for example, and then the enrichment service will return through an API request information about the people that live within that area. So the population, the number of households, the household size, the counts by different genders, income information, other types of information that you can select. And we do the analysis within the enrichment service to find either the full areas, like the full block groups, or the partial areas that are done, that are intersecting that area you've defined, and then do the apportionment of that. So you get a precise estimate for whatever area you define, whether it's a regular area like a circle or an irregular area like a drive time area. You can also use the enrichment service to create rich reports and infographics like you see in the upper right. So here you can pass in one or more locations. You can specify the type of report or infographic you would like. You can do things like a buffer by distance or by drive time. And you can get back a report in a PDF format or an infographic in a graphic format that you can present to a user that has a very compelling user experience, and again, all properly apportioned information that you can share with your customers. And then lastly, if you have your own data, maybe it's store locations of yours, and you want to enrich your data with more information like demographic characteristics, you can use our enrichment capability to do that. You can specify again the area around your points, for example, your stores that you'd like to get information for, and then you can make the request. We will return that information to you, and then you can store that as an attribute of your data and use that for further visualization, analysis, and reporting. So some updates that are coming soon for our GeoEnrichment service. Every year we update our USA demographics, as I mentioned before. Those become available for mapping, but also for enrichment capabilities. With the next update in June, we'll be updating our US demographics. We'll also be updating many other countries around the world. We're also introducing some new capabilities in our infographics. We'll be integrating vector tile maps, like I talked about earlier, which will give you a higher quality infographics, sharper text and symbols. And then later this year, we'll be offering our high-res PDF output. So for infographics, if you get them in PDF format, you'll be able to get those in high-res format for higher quality display as well. So hopefully that gives you a good sense of the various types of location services available from Esri. There's a wide variety of mapping and other capabilities available. You can discover all of this content at the developer site, again, developers.arcgis.com. You can also discover a lot of this content at the Living Atlas at livingatlas.arcgis.com. I would encourage you to check those out, and if you'd like to learn more from me, you can follow me on Twitter and attend other events like this. So thank you very much for your time. Take care.